Hello everybody, this is the final video for Module 2 Math 025 on solving quadratic equations. And in this video we're going to look at applications of quadratic equations. So, why do we need them? Why do we solve them? So here's just going to give you some, real world applications to look at. So the first problem we have is a number and its square is 110. They want us to create the equation and solve it to find all the possible numbers that satisfy this statement. So a number, we don't know what that number is, so we're going to label that number x. Plus would be our plus sign, its square. So if we take x and we square it, it would be x squared. Is like equals in math, 110. So right now we have this equation. We have x plus x squared equals 110. So I know it's going to be a quadratic equation because I have that x squared term there. So let's write it in descending order and make it equal to 0 like we need to. So I'm going to make it x squared plus x is equal to 110. And I will make it equal to 0 by subtracting 110 from both sides. So now I have x squared plus x minus 110 equals 0. And what I'm going to do here now is I'm going to try to factor it to see if I can solve it. 110, I know, let's see, 1 and 110. 1 and 55, or not 1 and 55, 2 and 55. 10 and 11, and I know 5 goes into it, but I know I need a positive 1 here. So 10 and 11 will work because I have a plus and then a minus, so I'm going to have two different signs. So I need a positive 1, so I'm going to do x plus 11 times x minus 10 equals 0. And then I'll set them both to 0. So x plus 11 equals 0 and x minus 10 equals 0. So I'll subtract 11 from both sides. I get x equals negative 11. Add 10 to both sides. X equals 10. So our two solutions, the two numbers that satisfy this statement are going to be x equals negative 11 and 10. Okay, so here we need to find the product of two consecutive integers, and that is 420. So we want to write an equation and solve it to find all the possible numbers that satisfy this statement. So two consecutive integers. Like consecutive means one after the other. So like if I had the numbers 3 and 4, they are consecutive integers, and I just made them up. But we need the product, so it means multiplication. And we don't know what the integers are, but I know the first one, instead of calling it 3, I'm going to call it x because it's unknown. So I have x times, now we have to write it, we can only use one variable in our equations. So we have to write it in terms of x. So to go from 3 to 4, I added 1. To go from x to the next number, I would do x plus 1. I would add 1. So x plus 1. The product of two consecutive integers is, remember, is your equal sign, and it is 420. So now we have the equation. Let's simplify and solve. So I'm going to start by distributing first. So I have x squared plus x, or 1x, equals 420. Since it's a quadratic, we have to make it equal to 0. So I'll subtract 420 from both sides. So right now I have x squared plus x minus 420 equals 0. Again, we got to factor this, or we could do the quadratic formula. I think I'm going to try to factor it. And this is where I kind of mess around with my factors a little bit. I know 1 and 420, but that's not going to work because I need a 1 here. So I need some factors that are really close, or 1 away from each other. 2 and 210 will not work, obviously. So let's see here. I'm going to go to my calculator. I'm going to take 420 and let's divide it by 20. What do we get when we divide by 20? Ooh, 20 and 21. Those are one away from each other. I'll need one positive and one negative. So when I go to factor it, I need a positive 1, so it's going to be x plus 21 times x minus 20. And then we'll set both of those to 0. So we have x plus 21 equals 0 and x minus 20 equals 0. So we'll subtract 21 from both. So x equals a negative 21. And this one will add 20 to both sides. So we get x equals 20. So my two solutions to this problem are negative 21 and 20. Now, this equation does say the product of two consecutive integers is 140. Fine. Create the equation and solve it to find all possible numbers that satisfy this statement. So now we know what x is, but we do need to find the consecutive number after that. So we have negative 21 plus, or let's start with 20. So 20 and 21 will work, obviously. Or it's going to be negative 21, and if we're adding a 1 to that, it would be negative 20. And those would be our two consecutive integers that would multiply to give us 420. All right, so here we are looking at the product of two consecutive odd integers is 195. So again, odd, like if we went from 3, we would go to 3 to the next odd number, which would be 5. Now, again, we need a product, so I'm going to use x to represent my first odd number. And now, instead of adding 1 to get to that next number, we would add 2. So my two consecutive odd integers can be represented by x times x plus 2. And it says is 195, so equals 195. Again, let's multiply it out. We'll distribute, so we have x squared plus 2x is equal to 195. And then we want to make it equal to 0 so we can solve. So I'll subtract 195 from both sides. I end up with x squared plus 2x minus 195 equals 0. All right, 195, we need to factor that. Let's see, I know 1 and 195, but that's not going to help me. I need a 2 in the middle. I know I can divide it by 5, but 5 and 39 won't help. So 195, this is why I start looking at the teens. Let's try 15. Ooh, 195 and 15 can be found by multiplying 15 times 13. And that will give me a difference of 2. So when I go to factor it, because I need a negative 195 and a positive 2, we're going to do x plus 15, x minus 13 when I factor. And then we'll set them to 0, so x plus 15 equals 0. And we'll subtract 15 from both sides, so x equals negative 15. And then we have x minus 13 equals 0. We'll add 13 to both sides, so x equals 13. Okay, and here we are going to look at, is this right triangle a right triangle? Verify using the Pythagorean theorem. And if you recall, our Pythagorean theorem for right triangles says if each leg squared, so a squared plus b squared, is added together, then it will equal the hypotenuse squared. And the hypotenuse is always the side opposite that right angle. So the sides that make up the leg, or the right angle, are your legs. So to verify that this is a right triangle, I'm going to do 10 squared plus 24 squared, because this would be where that right angle would be if it's a right triangle. And that should be equal to 26 squared. So let's see here. 10 squared is 100. 24 squared is 576. And 26 squared is 676. So if we look at that, if I do 100 plus 576, I do get 667. And that is equal to 667. So this is indeed a right triangle, and we proved it using our Pythagorean theorem, which again is a squared plus b squared equals c squared. And it's saying if you take each leg and square it, and then add them together, it should be equal to the hypotenuse of that right triangle. All right, now we are going to use that Pythagorean theorem to find the length of the sides of the triangle below. We're assuming it's the right triangle, so that means we're going to use that Pythagorean theorem. So my legs are 5 and x minus 1, so I would have 5 squared plus x minus 1 squared equals x squared. So let's go ahead and simplify this. So we have 25 plus, and then we have to do x minus 1 times x minus 1 equals x squared. So we have 25 plus, when we FOIL, we get x squared minus x plus 1 equals x squared. So that's going to give me 25 plus x squared minus 2x plus 1, or I'm going to take that 1 right there, and I'm going to add it to the 25, so it's going to be 26 equals x squared. And now we want to go ahead and make it equal to 0. So I'm going to subtract x squared from both sides, which is kind of nice because then I have 26 plus the x squared cancels out on that side, or 26 minus 2x equals 0. So here I just need to solve it, and to do that, I'm going to factor out, I'm going to write it in descending order first. So I'm going to write it like we should see it, negative 2x plus 26 equals 0. And then I'm going to factor out a negative 2. So it's going to be negative 2 times x minus 13 equals 0. So now that I have that, I'll take each factor and set it to 0. Now my negative 2 equals 0. We know that doesn't work. So if it's just a number, we don't worry about it. But the x minus 13 equals 0. We can use that and we'll solve it. So we'll add 13 to both sides. So x equals 13. And then I can use that to find the lengths of my sides. So I know this side is 5 over here. But we'll do 13 minus 1 to get the other leg. So it is 12. And then x is equal to 13. So my lengths of the sides of my triangle are 5, 12, and 13. Okay, now for this one, they want us to find 3 consecutive even integers that satisfy the Pythagorean theorem. And it says, hint, solve the triangle below to answer this. So we're going to use our Pythagorean theorem to solve this. We've got our 2 legs and our hypotenuse here. So we're going to have x squared plus x plus 2 squared equals our hypotenuse of x plus 4 squared. So we're going to FOIL this out. We have x squared plus x plus 2 times x plus 2 equals x plus 4 times x plus 4. All right, we got a lot of work to do here. So we have x squared plus x squared plus 2x plus 2x plus 4 equals x squared plus 4x plus 4x, and I'm just foiling here, plus 16. So let's combine our like terms, x squared and x squared. When we get 2x squared plus 4x plus 4 is equal to x squared plus 16x plus 16. And what I want to do here, oh my gosh, that's not 16 right there in the middle. 4 plus 4 is 8. Jeez, a whiz. All right, x squared plus 8x plus 16. Sorry. So now we're going to combine our equations, set it equal to 0 so we can solve. So I'm going to subtract x squared from both sides. I'm going to subtract 8x from both sides. And I'm going to subtract 16 from both sides. So we're going to have x squared minus 4x minus 12 is equal to 0. Let's factor that. 2 minus signs means I need a plus and a minus. To get 12, 1 and 12, 2 and 6, 3 and 4, and I need a 4. So we're going to do 2 and 6. And let's see here, I need a negative 4, so a negative 6 and a positive 2. So now, x plus 2 equals 0, and x minus 6 equals 0. So when I solve these, I get x equals negative 2, and I get x equals 6. Now, these are both solutions to the equation that I wrote, but I am finding the length of the sides of a triangle. If I plug in, or if I use the negative 2, that would mean that this side right here would be negative 2. Since we don't measure, we don't have negative measurements, it would start at 0 or nothing, then negative 2 is not a solution that I can use in this equation. It doesn't work for what we're doing. Put it back in there, just cross it off. Okay, but the 6 will work. So now if I do my sides, and we're finding 3 consecutive even integers. So this side is 6. 6 plus 2 equals 8 for the other side. And then 6 plus 4 will give me 10. And 6, 8, and 10 are 3 consecutive even integers. Find the length of the side in the square below if its area is 69 meters squared. So remember, to find the area of a square, you take and you do side squared equals the area. So we know one side is 3x, so I'm going to take my 3x and square it, and I know the area is 169 meters squared. So we're going to solve this equation to find x. So first, let's see here. We'll square 3x, and that will give us 9x squared is equal to 169. Now it is a quadratic, so I do want to make it equal to 0, so I'll subtract 169 from both sides. And I end up with 9x squared minus 169 equals 0. Now I do want to factor this. And I do have 2 terms here with subtraction, and they're both perfect squares. So this will factor as our difference of perfect squares. So it would factor as 3x minus the square root of 169 is 13 times 3x plus 13 equals 0. And again, the minus and the plus, doesn't matter which one you put first. So now let's solve those equations. We have 3x minus 13 equals 0, and 3x plus 13 equals 0. So the first one, I'll add 13 to both sides. I get 3x equals 13. And then I'll divide by 3. So x equals 13 thirds. And then here I will subtract 13 from both sides. So we get 3x equals negative 13. Divide both sides by 3, we get x equals negative 13 over 3. Now again, I'm finding the length of a side of a square. Measurements, we're not going to have negative measurements. So even though this negative answer is a solution to the equation, it's not a solution to the problem we're solving. So we will use this, x equals 13 thirds. And if I multiply 3 times my 13 thirds, those 3's will cancel out. That means that each side of this square equals 13. All right, so here we are going to find the length of each side of the rectangle. If the area is 84 centimeters squared, and remember, area is equal to length times width. So we are going to do, our area is 84, and that will be equal to my length and my width. So x plus 3 times x minus 2. So I guess we got to FOIL first. So we'll have 84 is equal to x squared minus 2x plus 3x minus 6. And then we'll simplify that. So 84 is equal to x squared plus x, because negative 2x plus 3x equals x, minus 6. And now we got to make it equal to 0, so I'm going to subtract 84 from both sides. And that will give me 0 is equal to x squared plus x minus 90. And now when I go to graph this one, I need something to add to 1, but give us a negative 90. And I know that 9 and 10 give me 90. So x and x, we're going to use 9 and 10. I need a positive 1, so positive 10, negative 9. And then we'll go ahead and solve those. So x minus 9 equals 0, and x plus 10 equals 0. X minus 9, to solve it, I would add 9 to both sides. So x equals 9. On the other side, I would subtract 10 from both sides. So x equals negative 10. Again, because we're finding lengths of the sides of a rectangle, that negative 10 for us will not work. We won't use it. But x will equal 9. So my sides of my rectangle are 9 plus 3, which gives me 12. And then 9 minus 2 gives me 7. So my dimensions are 12 and 7 for the rectangle. All right, so here for the last one in our geometry section here, we're going to find the dimensions of the triangle if the total perimeter is 112 inches. Now remember, to get perimeter, you add up all the sides. So that's what we're going to do here. We are going to add up all of my sides. So I will have x squared plus 3x minus 1 plus 4x minus 7, and that will be equal to 112. Now let's combine like terms here. So it becomes x squared plus 7x minus 8 equals 112. Now I do want to make that equal to 0, so I'm going to subtract 112 from both sides. That's going to give me x squared plus 7x minus 120 is equal to 0. All right, now we got to find those factors of 120. Let's see. I know 1 and 120, but that won't help. 2 and 60, not going to give me a 7 there. 3 and 40 doesn't help me either. 4 and 30, I should have known that. 5 and 24. No, we're not there yet. 120 divided by 6 is 6 and 20. Not there yet. 7 would not work. 120 divided by 8, though. 8 and 15. Ooh, I like that one because 8 and 15 will give me a 7 when I do subtraction, and I need one positive and one negative number. So we're going to use 8 and 15, and I need a positive 7, so the 15 is bigger, it'll be positive. The 8 is negative, so it'll be... All right, then we solve it. So x minus 8 is equal to 0, and x plus 15 is equal to 0. Add in your 8's. So x equals 8. Subtract 15. X equals negative 15. But again, we're finding lengths here. So that negative 15 will not work. We'll use 8. So that means one side of my triangle, if I do 8 squared, is 64. Then 3 times 8 minus 1. 3 times 8 is 24. Minus 1 will make it 23 for that dimension. 4 times 8 is 32. 32 minus 7 is going to give me 25. So my 3 dimensions are 64, 25, and 23. All right, our next application is talking about a rectangular painting. And we know the width of a rectangular painting is 5 inches longer than its length. If the total area is 300 square inches, find the dimensions of the painting. All right, well, we know that here is our painting. All right, and the width is 5 inches longer than its length. Well, here's my length, and I don't know what that is, so that's going to be x. The width is 5 inches longer, so that would be x plus 5. So area, remember, is, again, length times width. So we're going to do 300 is equal to x times x plus 5. Let's distribute. So we get x squared plus 5x is equal to 300. We got to make it equal to 0, so I'll subtract 300 from both sides. So that is going to give me 0 is equal to x squared plus 5x minus 300. All right, now we need to factor that. Let's see, for 300, I know 1 and 300 is not going to work. 2 and 150 won't work. 3 and 100 won't work. 4 and 75 won't work. 300 divided by 5 should be 60. 5 and 60 still doesn't work. I need a 5. 300 divided by 6. 6 and 50. 7 won't work. 8 won't work. 9 won't work. 10 and 30. But that won't work. Let's see here. Let's try 300 divided by, let's try 15. Ooh, 15 and 20. All right, I need a difference of 5. That'll work. So then when we factor it, we need a positive 5. So x plus 20 times x minus 15. And set them to 0. X plus 20 equals 0. X minus 15 equals 0. So we'll subtract 20 from both sides. X equals negative 20. add 15 to both sides here, x equals 15. Now again, we're talking about dimensions on a picture, so even though they're both valid answers for the equation, the negative number won't help us with our dimensions, so our dimension, x, is 15, so the dimensions of the picture are 15 by 15 plus 5, so 20. So my dimensions are 20 and 15 for the painting. Okay, so now we are going to take a look at a problem where we have a rock that is dropped off a 400-foot cliff. The height of the rock from the bottom of the cliff is represented by the quadratic equation h equals negative 16 t squared plus 400, where t is the time in seconds. Find the following. What is the height after 2.3 seconds? Well, 2.3 is our time here, and that's our t. So to find a, we just have to do some math. We want to find the height after 2.3 seconds, so we're going to take and plug it into our equation. So we're going to do 2.3 squared times negative 16, and then add 400 to it, and I get 315.36. So that means it is 315 and 36 hundredths feet from the ground. So after 2.3 seconds, it has fallen down. It started at 400 feet. It's down to 315 feet, roughly. For B, when does the rock hit the ground? Hint, h is 0. When it hits the ground, the height would be 0. So now we're doing 0 equals negative 16 t squared plus 400. So let's take a look at this one. Sometimes you can factor these, sometimes you can't. For this one, for 16 and 400, I know that I can pull out an 8. I don't think I can pull out a 16. Let me see. Oh yeah, I can. So I can factor out a 16 here. So I'm going to factor out, because it's a negative, I'm going to make it 0 equals negative 16 times t squared minus 400 divided by 16 is 25. Well, that makes it nice because now we have difference of perfect squares right here. So we have 0 equals negative 16 times t plus 5 and t minus 5. So we're going to take our factors with variables in it, so not that negative 16. T plus 5 equals 0. T minus 5 equals 0. And let's see, we'll subtract 5 from both sides here. So t equals negative 5, and add 5 here. So t equals 5. Now t represents our time, and we have to look at our two solutions here. We have a negative 5, which would be we're going back in time, or we have a positive 5. This is going to represent when the rock was thrown, but it's going to take 5 seconds for it to hit the ground, and that's the value that we want to look at there. So now, for the last part, how long does it take? So the rock is 300 feet from the bottom. Well, that 300 feet is the height. So now we have this equation. We have our height is 300, and it's going to be equal to negative 16 t squared plus 400. So the first thing we need to do is make it equal to 0. So I'll subtract our 300 from both sides. We get 0 is equal to negative 16 t squared plus 100. I know that I can pull out a negative 4 out of here. So I'm going to factor out a negative 4. So that way we with 4t squared plus or minus, it's a negative 25. Again, I factored out a negative 4. So now, again, to kind of help us out here, difference of perfect squares, 2 perfect squares subtraction. So 2t plus 5 and 2t minus 5. So we'll set them to 0. Again, not worrying about that negative 4. 2t plus 5 equals 0. Means I'll subtract 5 from both sides. 2t equals negative 5, divide by 2. So we get t is equal to negative 5 halves, which again, do we want that negative? No, because we're talking about time. So let's look at the other equation. We have 2t minus 5 equals 0. We'll add 5 to both sides. So 2t equals 5. Divide by 2. T equals 5 halves. Or because we're talking about time, and we're talking about seconds, I would change this into a mixed number and make it 2.5. So it's 2.5 seconds that it takes. Okay, so now we have our last problem for this section for applications with quadratics. And it's similar to the one we just did. We have another object, and this time the object is thrown upward from the top of an 80-meter building with an initial velocity of 64 meters per second. They want us to find the height of the object after t seconds, and the equation, or the height of the object after t seconds, is given by the equation of h, where the height is equal to negative 16 t squared plus 64t plus 80. And we need to find the following. We need to find the height after 1 and 3 seconds. And how is this possible? Well, when does the object hit the ground? And remember, that would be, the height would be 0 when it hits the ground. And then how long does it take for the object to be 44 feet from the bottom? So for this one, we're going to start off for 1 and 3 seconds. We're going to evaluate our equations. So I'm going to take my negative 16, and instead of time, or t, I'm going to put my 1 in there. So 1 squared plus 64 times 1 plus 80. So really, that one, because we're multiplying by 1 here, it's negative 16 plus 64 plus 80. And that is going to equal 128. So excuse me. So it's 128 meters off the ground. After 3 seconds, we're going to do negative 16 times 3 squared plus 64 times 3 plus 80. And that equals, let's see here, 3 squared is 9, negative 16 times 9 plus 64 times 3 plus 80 equals 128 meters. Now, how is that possible? Why are they the same? And I want you to think about this. These equations form a parabola when we graph it. So remember, the shape of a parabola, it's got that vertex at the top. Whatever goes up must come down. So here's like 1 second at 128 meters, and there's 3 seconds. So they're both, at 1 second, it's still going up because it's thrown upward. But then at 3 seconds, it's coming down and it's at 128 meters. Now they want to know, when does the object hit the ground? So h would be 0. So we're going to have 0 is equal to negative 16 t squared plus 64t plus 80. And let's see here. I know that I can factor out a negative 16 out of this, actually. So we're going to factor out a negative 16. So that will leave me with t squared minus 4, I believe. Yep. Minus 4t minus 5. And to solve it, we're going to graph this inside. So t, the only way I can make 5 is 5 and 1. I need one positive and one negative. So a positive 1 and a negative 5 because I need a negative 4. And that means that if we do t minus 5 equals 0, we'll add 5 to both sides. So t equals 5. And here, I'll just show you, but you should know by now, like, that's going to give us a negative answer. We don't want the negative answer. We're talking about time. So in 5 seconds, the object will hit the ground. Now we need to figure out how long does it take for the object to be 44 feet from the bottom. So what I'm going to do here is I am going to erase some of the stuff so we have space to work. So again, if you want it and you haven't written it down, pause the video, make sure you write it down. And let me do a little erasing so that we can do the last part of the problem. The last problem for this video and for this module. Okay. So how long does it take so that the object is 44 feet from the bottom? 44 would be our height. So we'd have 44 here equals negative 16t squared plus 64t plus 80. Now we do have to make it equal to 0, so I'll subtract 44 from both sides. And that will give me 0 equals negative 16t squared plus 64t plus 36. Let's see here. We can pull out an 8. No, but we can pull out a 4. So I'm going to factor out a negative 4, and let's see what we get. It's going to give me 4t squared minus 16t minus 9. Let's see here. Can we factor this? Let's try the box and see. All right, so we have 4t squared, 9, and then we need our t's over here. Okay. So 4 times 9 is 36. My factors of 36 are 1 and 36, 2 and 18, and I need in the middle, I'm going to need a negative 16. Okay, so we can do 2 and 18. I'll have one positive, one negative, so I need 18 to be my negative and 2 to be my positive. Let's factor across. 2t and 9, my GCF would be 1. 4t squared and 18t, my GCF will be 2t. For 4t squared and 2t, my GCF will be another 2t. And 18t and 9 would be 9. So it factors to 2t minus 9 times 2t plus 1. And we're going to set those to 0, because again, we don't really need to worry about that negative 4. It's not going to work. 2t minus 9 equals 0. When we solve it, we'll add 9 to both sides. So we get 2t equals 9, divide by 2. So t equals, and because we're talking about time here, I am going to simplify it. 9 divided by 2 should be 4.5 seconds. The other one, 2t plus 1, if we solve it, you should know by now, it's going to give me a negative answer. I don't want the negative answer. I'm talking about time. We're not going back in time. So 4.5 seconds until it reaches the ground, or it's 44 feet from the ground. All right, that's it for Module 2.